This thing came from deep space, not in our system, not from your Oort cloud or your Kuiper
First
belt.
time ever, an object from interstellar space has been observed to visit our solar system.
Now, this thing's got to be like a ship.
In October 2017, astronomers discovered something that had never been seen before in human history. An object from somewhere else, not from our sun, not from our galaxy's gravitational neighborhood, but from beyond, from interstellar space itself. They named it Oumuamua, a Hawaiian word meaning first messenger from another world. And this messenger brought with it a mystery that would divide the scientific community in ways few discoveries ever have. A mystery so profound that even now, 7 years later, we still don't have a definitive answer. What was Oumuamua? Where did it really come from? Why did it do something that violated everything we understood about how objects move through our solar system? What if an object could accelerate without showing any signs of how it accelerated? And what if there were theories so extraordinary, so out of the box, that they challenged the very foundation of what we thought was possible in physics? Welcome to the Cosmos Quest. In this video, we're going to explore one of the most captivating mysteries in modern astronomy. We'll trace the collision between science and the unexplained. We'll examine the enigma of Oumuamua's impossible acceleration, and we'll investigate the competing theories, some conventional, some radical, that scientists are using to make sense of this cosmic messenger. And you'll understand why this small interstellar object has sparked a scientific revolution about how we think about the universe around us. In October 2017, the Pan-STARRS Observatory in Hawaii detected an unusual object moving through our solar system. The initial readings were remarkable. Oumuamua was traveling at approximately 92,000 kilometers per hour, incredibly fast, even by cosmic standards. But what made it extraordinary was its trajectory. Its orbit was hyperbolic, which means it was on a one-way journey through our solar system. It didn't originate from our sun. It didn't come from the Kuiper belt or the Oort cloud. Its velocity and trajectory were so precisely aligned with the mean motion of stars in our galactic neighborhood that scientists concluded it had to have come from another solar system somewhere out in interstellar space. Oumuamua was shaped like nothing we'd ever observed before. Somewhere between a pancake and a cigar, approximately 115 meters long by 19 meters thick. Astronomers observed its reddish hue, a color that suggested an ancient surface heavily bombarded by cosmic radiation over billions of years. For about 2 weeks, telescopes around the world tracked this cosmic visitor. In those 14 days, it provided us with more mystery than clarity. As Oumuamua exited our solar system and headed back into interstellar space, astronomers expected its trajectory to follow a predictable path. They knew the sun's gravity. They could calculate the expected acceleration due to solar gravity alone. They had the data, the observations, the mathematics. But when they analyzed the object's movement, something didn't add up. Oumuamua was accelerating faster than gravity alone could explain. The non-gravitational acceleration was small, just 5 micrometers per second squared. But it was undeniably there. Detected with 30 sigma significance, meaning the probability of this being a measurement error was virtually zero. Now, here's where the puzzle deepens. For ordinary comets in our solar system, this acceleration would be completely normal. When a comet approaches the sun, the heat vaporizes its surface. Water ice, frozen carbon dioxide, and other volatile materials sublimate into gas. These gaseous jets create thrust, like the engines of a rocket, that slightly alter the comet's trajectory and speed. This phenomenon is so common that astronomers see it in nearly every comet they observe. The signature is unmistakable and clearly visible from Earth. A comet's outgassing creates two telltale features. First, a coma, a luminous, hazy cloud of dust and gas surrounding the nucleus. Second, a tail, sometimes millions of kilometers long, swept back by solar radiation and solar wind, creating a spectacular beacon that's often visible to the naked eye. Oumuamua had neither. No coma, no tail, no visible evidence of outgassing, no apparent trail, nothing that resembled the classical picture of a comet at all, yet it was accelerating as if it were outgassing. This was the core of the mystery. This was the paradox that would launch 1,000 theories. So what was really happening? The scientific community proposed several explanations, each more fascinating than the last. The first theory proposed that Oumuamua was simply a comet, but a very unusual one. Perhaps it was a dark comet, a comet that was outgassing, but the gas was invisible. In 2023, researchers Jennifer Bergner and Daryl Seligman published groundbreaking research in the journal Nature. They proposed that Oumuamua is a water-rich planetesimal that had been traveling through interstellar space for billions of years. During this journey through the cosmic void, it was bombarded by high-energy cosmic radiation. This radiation cooked the surface of the ice, creating molecular hydrogen, H2 ice, within the body. When Oumuamua entered the inner solar system and warmed up, this hydrogen escaped. Because hydrogen is invisible, it doesn't scatter light. There would be no visible coma or tail. But the outgassing would still produce thrust. For a small object like Oumuamua, even invisible hydrogen outgassing could produce the observed acceleration. But this explanation has faced criticism. Physicist Niels Lichterink challenged the hydrogen hypothesis, proposing that it's unlikely sufficient hydrogen could be trapped and later released to produce the observed acceleration. He suggested that if this explanation is correct, Oumuamua must be substantially older than previously thought, perhaps older than 500 million years, and must contain unusual ice compositions like methanol. Other researchers proposed entirely different solutions. Some suggested Oumuamua could be a fragment of nitrogen ice ejected from a Pluto-like planet orbiting a distant star. Nitrogen ice, when heated, sublimates similarly to water ice and could theoretically provide the mysterious acceleration. Then there's the solar sail hypothesis. What if Oumuamua isn't a ball of ice at all, but something far more exotic? What if it's an extremely low-density, delicate structure, perhaps composed of filaments or strands of material so light and reflective that solar radiation pressure alone could push it outward? Imagine a cosmic snowflake, so delicate and so perfectly oriented that the sun's photons could accelerate it without leaving any observable trail. And then there are the fringe theories. Harvard astronomer Avi Loeb has been the most vocal proponent of a controversial hypothesis, that Oumuamua might be an artificial object, a solar sail deliberately constructed by an advanced extraterrestrial civilization. A probe or artifact sent across the stars to explore the galaxy. Loeb argues that its unusual shape, its lack of a tail, its mysterious acceleration, and the fact that it appears to be on its first close approach to any star all suggest intelligent design. While most of the scientific community views this theory with extreme skepticism, Loeb's willingness to entertain radical possibilities has helped reshape the conversation about what Oumuamua could be. What makes Oumuamua so important isn't just the object itself, it's what it represents. For decades, we believed we understood our solar system completely. We knew the rules, we knew how objects should behave. Oumuamua challenged those assumptions. The discovery proved that interstellar objects regularly pass through our solar system. In 2019, just 2 years after Oumuamua's visit, another interstellar comet arrived, 2E Borisov. This one behaved more classically, with a visible coma and tail. Even more remarkably, scientists later determined that a meteor that struck Earth in 2014 also came from interstellar space. We weren't looking for these visitors before. Now we know they're out there. The Vera C. Rubin Observatory, which began operations in 2025, is specifically designed to find more of these objects. Scientists estimate it will detect between 1 and 3 interstellar comets like Oumuamua each year. Each discovery promises to teach us about solar systems billions of miles away. Each one might reveal new physics, new chemistry, new possibilities. There is a detailed video about the Vera Rubin Observatory in our channel, which you can see by clicking the I button. The truth is, we still don't have a definitive answer about Oumuamua. The mystery persists. Oumuamua is now far from the sun, growing dimmer each day. It's heading back into interstellar space, continuing its eternal journey. Multiple missions have been proposed to catch up with it, some using revolutionary propulsion systems, others using gravitational assists from Jupiter to gain speed. The Institute for Interstellar Studies proposed launching a spacecraft in 2028 that could reach Oumuamua around 2054, but those are future possibilities. For now, Oumuamua remains an enigma wrapped in cosmic mystery, and that mystery is beautiful. But Oumuamua isn't the only interstellar visitor that has captured our attention. In 2019, the world's astronomical community discovered something equally remarkable. Another messenger from beyond our solar system arrived, 2I Borisov. And its story, its origins, its composition, its trajectory, is no less fascinating than Oumuamua's mysterious acceleration. Speaking of intriguing objects from beyond our solar system, if you're curious about the recent studies and mysteries surrounding 3I Atlas, please check out our next video explaining what makes this object so intriguing and what it might tell us about the universe. What's your theory about Oumuamua? Do you think it's an ancient comet with hidden hydrogen, a nitrogen ice shard, a solar sail, or something we haven't even imagined yet? Share your thoughts in the comments below, and if this deep dive into cosmic mysteries has fascinated you, subscribe to The Cosmos Quest for more expeditions into the universe's greatest unanswered questions. Until next time, keep looking up and stay curious.